Okay, some more exercises from section 9.4. This is number 51. And again, we're going to have to use partial fractions to kind of break this up and get a separation. Here's a couple of, separate this into a couple of terms. So you can use the telescoping series approach here. All right, sorry about that. There we go. So I've got 2n plus 1. So I've got a over n squared plus b over n plus 1. And that's going to be equal to 2n plus 1. So we just cross multiply. So we have a n squared plus 1, or I'm sorry, a plus 1 squared, pardon me, b to n plus 1, and then I've got 2n plus 1. And then if I use n equal negative 1, that'll get rid of the a term, and I'll have b times negative 1 squared, which is just b. And if I put negative 1 here, I've got 2 times negative 1, which is negative 2 plus 1, which is negative 1. So b equals negative 1. And then I could put 0 in here to get rid of the b term. And then 0 plus 1 is just 1. So a just equals 2 times 0 plus 1, which is just 1. So that was easy enough. So we can rewrite this summation as this summation. Sloppy. There we go. Alrighty. Hope I was putting parentheses about my other ones. Yes, okay. And then we can write out a few terms. Also, when s is 1, I get the first sum, so that's going to be 1 over 1 minus 1 over 1 plus 1 is 2, 2 squared is 4, so that's just 1 minus 4. Then my second partial sum, I'm just going to add to this s sub 2. So n equals 1, and then n equals 2, so I'm adding up the 1 and the 2. So this is the 1 I had from up here, and this is the 2 because I'm going to go out to s sub 2. Partial sum, first two terms, pardon me. This is the first term. This is the second term, so I'm going to put 2 in here, 1 over 4. 2 plus 1 is 3, 3 squared is 9, and these scores are combined, so I end up with 1 minus 9. And then I can again group these up, and I'll add the third term. So it's going to be 1 over 3 squared is 9, minus 1 over 3 plus 1 is 4, so 4 squared is 16. And you can see how these are grouped. These are grouped. So I end up with 1 minus 16. So if I take the limit, this is going to be the s sub 1. I can write this as 1 minus, and I can come up with a general term. This is going to be 3 plus 1 squared, so 1 minus 1 over 3 plus 1 squared. And then if I take the limit as n approaches infinity, this is going to go away, and I'm just going to have 1. So there we go. So that's number 51, and number 52, we didn't have to do the partial fractions. They broke it up for us, so we could just write out a few terms. Okay, again, write out a few terms to see what's going on. So we've already got our general term there as a binomial. So first term would be 1 over 1 minus 1 over the square root of 2, so it's going to be 1 minus the square root of 2. Second one, I'm just going to add to this 2, 1 over the square root of 2, plus minus 1 over the square root of 3. And these are going to combine, so 1 minus the square root of 3. And the third one, 1 minus the square root of 2, plus the square root of 2 minus the square root of 3. And then it's going to be plus the square root of 3 minus the square root of 4, which is 2, but I can just write it like this to see the general form. So s sub n is going to be 1 minus, and this looks like this is going to be 1 over, in each case it's n plus 1, so the square root of n plus 1. If I take the limit as n approaches infinity, this is going to get really, 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 really big, so it's going to become 0. That's going to go to 0, so my answer would just be 1. So that's 52. And where's 53? Here's 53. And again, they gave this to us. One over the natural log of n plus 2 minus the natural log of n plus 1. So when s is 1, 1 plus 2 is 3. 1 plus 1 is 2. So 1 over the natural log of 3 minus 1 over the natural log of 2. And that's my first two terms, and then I can add this one to be the second term. So that's going to be 3 and 4. You know, we add 1 to 2, or 2 to 2, we get 4, pardon me. And this is 3. So 2 plus 2 is 4, 2 plus 1 is 3, natural log of those. And you can see how the natural log of 3's are going to cancel. This is interesting. I have the natural log of 4 minus the natural log of 2. So it's a little bit different. Okay? And then I'll add the next one. This is going to be the natural log of 5. 3 plus 2 is 5, plus the natural log of 4. And what happened is the 3's will combine, the 4's will combine, so I got the natural log of 5 minus the natural log of 2. So my general term, this looks like, for 3, this looks like the natural log of n plus 2. And in each case, I have the natural log of 2, so I just have the natural log of 2. Because all the other ones would cancel. So it looks like, well, I didn't carry it out, but it looks like if I carried it out, the natural logs, the next ones would cancel. So it looks like this is the natural log of n plus 2 minus the natural log of 2. And if I take the limit as this goes to infinity, this is going to go really, really big, and the natural log of that's going to go really, really big, so that's going to go to 0 out. Oops, pardon me. So I end up with just the natural log, minus the natural log of 2. Okay? Those are just going to keep canceling out like that. Okay, so I hope those help.